Okay, good afternoon, everybody. My name is Vishnu Nath. I am the program manager who's owned the network monitoring feature coming in Operations Manager 2012. And I am really excited to be here in the beautiful Venetian ballroom here to be able to present to you guys a lot of the hard work and dedication that went into delivering this feature, which is such a really big, monumental and big feature add for Operations Manager and for System Center as a whole. I'd like to get started here on time so that I can get you guys out of here on time. I realize this is one of your last sessions of the day, so I want to make sure I can be respectful and end punctually. So let's get started. So I'm going to frame this presentation here today kind of in four key areas and how I'm going to walk you through the story that we developed for network monitoring in Operations Manager 2012. So we're going to go through kind of the experience we built around discovering your network topology. We're going to touch on some of the monitoring views and aspects that we built out and exactly what we're able to monitor out of the box and how we can extend monitoring even beyond that. We're going to touch on some of the visualization pieces. So if any of you in the overview session or have taken a look at Operations Manager 2012, you've seen that we've made a significant investment in dashboards. And I'm happy to announce that the network monitoring feature will come with a set of dashboards out of the box for you. Lastly, we'll touch on some of the reports. So again, we wanted to ship a set of usable reports for you out of the box that you could leverage with network monitoring without having to do any report authoring yourself. But the one key takeaway I want you all to get from this session is to really understand how, with this feature, Operations Manager will help IT operations gain visibility into their network layer of services in order to reduce their mean time to resolution. Now, when we talked to many of you customers over the last few years when we were developing this feature, not only was this one of the most asked features in the history of Operations Manager was to give us visibility in the network layer, the conversations usually went something like this when I talked to my customers, and specifically my traditional Operations Manager customers, which tended to be the IT ops guys. They'd often tell me, you know, Vishnu, you guys do an awesome job. You have best-of-class monitoring for Microsoft workloads like SQL and SharePoint and Exchange and all of these things. You guys do some cross-platform monitoring. But if I'm actually doing my day-to-day job and I get to a problem, let's say I've got a service or an application that's behaving slowly or is unavailable, I can whip open my operations console, I can go through the views, I can try to figure out what's going on. But at the end of the day, I end up scratching my head and saying, you know what, everything looks okay here. You know what, maybe, just maybe, there's a network problem going on. Let me call my network guy. And usually they're not as enthusiastic as how I just was. Usually it's like, oh my God, I have to call the network guy. Or I got to open a ticket for the network guy. Okay, so I hear some of you laughing because this is a common story I've heard from numerous customers. So they open a ticket, call over to the network guy, say, hey, you know, XYZ application's behaving slowly, or some of my users are reporting an outage. Can you take a look? Is there something going on in the network? Almost instantly, response, nope, network looks good to me. My dashboard's looking good. Sorry, we'll take a look at it, but most likely the network's fine. 6 hours to a day, maybe even more than a day comes back before they come back and say, okay, maybe there was a network problem that was affecting you. But what we want to do is provide IT ops visibility immediately within that same tool that they're used to using with Operations Manager for them to be able to pinpoint when there's a network issue with one of their network devices or with one of the ports that one of their servers connected to, and really be able to give them that pane of glass to be able to stitch those network issues back to their applications, their servers that they're monitoring with Operations Manager. By doing so, they can then pick up the phone and call the network guy and say, you know what, on switch XYZ, port number 13 that's connected to my Exchange server, you know what, I noticed that this thing's flapping on and off. Can you guys take a look at that? Or can you guys reset that router for me because I'm having a problem? And immediately they can get the credibility and the amount of information they need to properly escalate the issue to reduce that mean time to resolution. So let's talk about how exactly we deliver that feature. So let me talk about one thing, out of the box experience. So when you want to add network monitoring to your Operations Manager 2012 environment, you do not need to do anything other than install the product. All of the required MPs, all of the requiring components for network monitoring ship as an out-of-the-box experience, including dashboards and reports that we've authored for the feature. We're also able to not only discover and monitor those network devices, but also discover how those devices are connected to each other and how they're connected to those servers that you really care about that you're monitoring and the subsequent applications that are running on those servers. We have support for over 80 vendors and over 2,000 devices certified. And I'd like to thank many of you in this room that have participated in our TAP program for this feature as we were going through our interim milestones, our CTPs, and our betas, because many of you in this room today helped us get to this certified number that I'm proud to announce here, in addition to the work we've done with Microsoft IT and GFS to validate that this feature is hardened and ready for you guys to consume and enjoy in your environments. From a protocol support standpoint, we are happy to say we support SNMP v1, v2, and v3. As we noticed in the field, a lot of SNMP v3 uptake is taking place, so we wanted to make sure that we could support that out of the box so that immediately you could leverage the security that comes with SNMP v3. We do have monitoring and discovery support for IPv4, and we do have support for monitoring IPv6 endpoints. So if we're able to discover your device and you have IPv6 endpoints, we're able to monitor those as well. So kind of going along with the SNMP v3 support, we also wanted to make sure we had monitoring support for IPv6 so that we can ensure that this feature is really ready for mainstream adoption. So what types of devices are we talking about? So obviously we're not just talking routers, switches, hubs. We're also doing things for other types of devices such as firewalls, load balancers, bridges, etc. So let's talk about how do we start this whole process? How do we get going with network monitoring? So discovery is really our process of identifying what network devices you want us to monitor. For us, the big objective for network discovery was to make it simple, that anybody, any IT ops guy with a community string could get up and running with network monitoring without having to be a network admin, without having to even call over to their network admin to help them walk through it. We want it to be simple, quick, and easy for them to be able to do it. And instead of talking to you guys, let's just jump right into demo, and I'm going to walk you through exactly what you would have to do when you go back and install Operations Manager 2012 and want to discover your network. We'll walk right through what that process looks like. So gotta have that, you know, I learned the hard way once. Okay, so let's start off in the administration workspace. So in administration workspace, you'll notice we've got a section for discovery rules, and I've got one network discovery rule that I created. You can launch the discovery wizard just like you would for Windows and cross-platform machines, Unix and Linux computers, and you'll notice we've added network monitoring to this view. So the experience is very similar to what you would have for discovering your Windows computers. Since I already have a rule created, I'm just going to pop it open, and we can walk through exactly what that looks like. So can everybody in the back see this, or would you like me to zoom? Just raise your hand if you can see it back there. Yeah, you're okay? Okay, so I'll try to zoom in on particular fields if they're hard to view. So the discovery rule lets us set up a discovery in a way that we can run the discovery again whenever we want to without having to enter in all of the properties for your discovery. It also allows us to run it on a schedule so that we can continually run your particular network discovery. So the rule gets populated by this discovery wizard. You'll notice right out of the gate we have the ability to specify what management server we want discovery to run from. So network discovery runs from any management server or gateway server that is contained in your network. Next, you can set, for monitoring, you can select any resource pool you want, or you can create a resource pool. So for any of you that were in the overview session, you'll know that server resource pools are Operation Manager 2012's answer to high availability. And I'm happy to announce that network monitoring takes full use of this resource pool functionality to provide you high availability monitoring out of the box. It's as simple as clicking the Create Resource Pool wizard in the UI, specifying a name for your resource pool, and adding whatever management servers you want to participate in your monitoring resource pool. Once you've done that, click Create, and you can quickly assign that pool over to be your pool to be using for network monitoring. By default, you'll notice we enumerate the All Management Resource Servers pool, which is a pool that contains all of the management servers in your group. We would recommend, if you're using this at scale, that you would use a dedicated pool of management servers to do your network monitoring so that that operation doesn't affect any of your other monitoring that's going on your management servers. Once you specify that, you'll select your discovery types. So when talking to customers of all sizes, we realize there's really two buckets of customers. There's some of our customers, which I would say is our 70% use case. And for them, we came up with what we call explicit discovery. Explicit discovery means you give us a list of IP addresses or DNS names for your network devices, and we'll go discover just those devices and bring them into Operations Manager. But when talking to some of our smaller, medium-sized shops, we learned that the IT ops role, the people within the company may not actually know what all the network devices are in their environment. So we needed to provide a solution for them to be able to start discovering some of the devices that are contained in their network topology. So we came up with recursive discovery. With recursive discovery, if they have maybe only one or two or three or maybe a small handful of the routers that exist in their environment, from there we're able to do essentially a web crawl of their network. What we do is we interrogate the ARP and IP tables on the routers, try to determine what other network devices exist in their environment, and essentially crawl their network, hopping from device to device, trying to find what all devices exist in their environment and return that back to them. So a lot of our customers that are small and medium sized that didn't have this visibility, they've really taken to this feature to be able to give them a list of all the network devices they want. Once they have this big list, some of them will then take a subset of those devices that they really care about and create an explicit discovery that they'll use for monitoring. So that's a very similar, that's a very typical use case we've seen. The next thing you want to do is create run as accounts for your community strings. So for those of you who don't know, community string is essentially a password that gives us read-only access to a network device and its MIBs and SNMP tables that we use to gather a lot of the monitoring data we use in the product today. And you'll notice I said read-only. We didn't want to require that users get a community string with write or configuration permissions because we knew that conversation would be difficult. We knew IT ops having to ask their network admin for a community string that wasn't read-only just wasn't going to happen. And if that's not going to happen, then this feature is not going to be useful. So we built the feature around the premise of only needing a read-only community string so that we could ensure that adoption of this feature would be able to be widespread throughout all of our customer environments. The reason we use a run as account is we want to be able to securely store those credentials on your management server. We don't want to keep them in clear text in a management pack or something that, you know, if any of you have used Operation Manager 2007, you might know that that was the practice at that point. In 2012, we leveraged run as accounts so that we can securely store those credentials, so there's no concern there that the credentials would be available. So once you specify a display name for your community string, you can specify the string itself and click Create. You can create any number of community strings that you want to monitor your network. I've talked to some customers who are very large and had several thousand devices, and they only use a single community string. Conversely, I've seen some customers that have maybe only 75 devices, but they have 75 community strings with SNMP v3, and they have essentially a one-to-one mapping of community strings to network devices. So we wanted to provide that flexibility for both types of customers within this experience. You can then specify or check any number of the community strings that you want us to be able to use for this particular discovery rule. Next, you want to specify what devices you want us to monitor. In the case of a recursive discovery, this may be a very small list. In the case of an explicit discovery, this may be a list that's several hundred or thousands of devices. To be able to bring those in, you can simply press import any text file that's basically one IP address per line, and we'll bring in all of those devices with smart defaults across the board so that you really don't need to do anything in majority of cases other than hit next on this screen and you're ready to go with monitoring. But I want to show you what some of the properties are available to you in this UI. I will mention that you can bulk edit these as well. So if you know you want to assign some properties across multiple devices, you can do a multi-select bulk edit. In the edit settings, you can see not only the name or the IP address that you specified, but also the access mode. So by default, we use ICMP and SNMP protocols to monitor a device. ICMP is going to provide us that ping, that responsiveness to ping that's going to allow us to show you how responsive your device is. And then SNMP is going to allow us to do some of that rich, deep monitoring of the device and its components and some of the performance and availability data that we really care about. You'll notice we also let you do one or the other. Now, when we talked to a lot of our customers and looked at a lot of the real-world environments, we realized there were going to be certain circumstances that wouldn't allow both protocols to be available. So we wanted to provide this flexibility. ICMP only, for example, one of the common scenarios for this is, let's say you have a telco router that your services are dependent on. Your telco is probably not going to provide you even a read-only community string to that device to be able to monitor it, but you still want to know if that device is up or down, because if that device goes down, it's seriously going to impact your applications and services. In that case, you could use an ICMP-only probe to be able to monitor the responsiveness of that telco router. Conversely, we know that customers have certain environments where ICMP traffic is not allowed because of their firewall, or if it's in a DMZ and they don't want ICMP traffic to be able to flow from a management server to the network device. In that case, we can do SNMP-only monitoring, and you can specify that here. We also allow you to configure what version of SNMP you want to use, SNMP v1, v2, and as I mentioned, the more secure v3. And then you can also specify which of the community strings you want us to use. Or by default, you can use the selected default accounts. And this is actually something really neat we did. So let's think, for example, let's say you have 1,000 network devices in your environment, and you have 5 community strings that your network team has assigned to use for a subset of those devices. Instead of having you do the mapping one-to-one of a particular community string to a particular device, we can do the mapping for you. So during discovery, we'll actually try each of the community strings. When we figure out which community string actually worked, we'll keep an internal mapping of the one that worked and use that for monitoring so that you don't have to worry about any of this assignment. So the real benefit there was to get you up and running very quickly with very little overhead and configuration. Now, I will mention one thing. I have seen in a small subset of customers that this could cause a potential hiccup in the case that a device is set up to generate a large number of traps if an invalid community string is sent to it. So I would do a public service announcement that if you're going to use this, maybe you want to give a heads up to your network team that you're going to be doing a discovery and you may have an invalid authentication attempt. But in majority of customer environments that we've seen, those traps usually aren't generated or they're not configured to generate those traps, so you should be good to go. Next, I'll click on the advanced discovery settings. So we wanted to surface the ability to be able to tune your discovery. We know that not all networks are the same. We have some networks that may have latency that is beyond what a typical network environment would be. So in that case, you can increase the ICMP or SNMP timeouts. You can also increase the number of retry attempts or decrease them as well. And then you can also tweak this maximum number of devices to discover. So by default, we set it at 1,500. But the reason we put this default in place was, with recursive discovery, we may end up discovering a whole lot of network devices that you may not even have known existed in your environment. And we don't want to go out and discover 10,000 devices, and you're stuck here now with 10,000 devices, and you're like, oh my God, I just wanted the 10 that were in this lab, and now I've got 10,000. So you can set a cap here so that our discovery will stop at a certain point and allow you to tweak your discovery rule to be more granular. Click Next. We have the ability now to pare down those results even more. So we can discover devices by some filters. So let's say I only care about routers, or I only care about switches. I can turn off the discovery filters for these other types of devices. I can also filter on name or object ID or description. And where I've seen this used a lot is, let's say you know all of your devices that you care about are actually in lab 46. And you know that lab 46 is prepended in the name of these devices, or it's listed in the description. You could then put a wildcard in here so that we know when we do a discovery to only discover those devices and not bother discovering anything else. Conversely, if you're fine with discovering everything, go ahead and leave it how it is. You can also exclude any devices that you want to be discovered. In the case of some environments, we've seen customers have some ISA firewalls or devices that, if they try to do a discovery, bad things may happen, or there's devices that they really don't care about us discovering and monitoring. You can add an exclusion here. Last, you have the ability to schedule when your discovery runs. We'd recommend running your discovery about once a week. What that will allow you to do is pick up any changes that have taken place in your network. If any devices were added or removed, if any connections changed, different servers that you depend on have moved ports and that type of thing. We'll pick all of those types of changes up during a discovery. So we would let you schedule it on an off-peak time, let's say Sunday at 3 in the morning when you know network activity is low and you don't need to impact any of your other services or applications. You also have the ability to run the discovery rule manually, which a lot of our customers do. Last, you get the summary page. When you hit save, that's it. End to end, that is the entire configuration from the operations manager perspective that you need to do to be able to discover your network, to be able to monitor it. When I click save, the discovery rule will ask me if I want to run it immediately or not. And if I say no, then it will run per the schedule you specified. Once discovery is run, you will see this screen right here. So it'll tell you sort of the name of your network discovery server, the status of the discovery, which will tell you whether it's in one of our 3 phases of discovery and how much progress it's made against that discovery so that you get some feedback about where the discovery itself is. You'll get the number of devices that were discovered. And you'll also get something we call last pending, which would be any devices we were unable to discover during your discovery process and the last time that your discovery rule was run. When you flip over to the network devices view here, you'll get a list of all the network devices we were able to discover and also the run as accounts that we use for those particular devices and the access mode that we are using to discover them. As I mentioned in the pending management view, this allows us to see any failed attempts to discover a device. So you'll notice I have this device I was unable to discover, and I can see that this device just didn't respond to ping. From here, I could actually either submit a rediscovery or pop open my discovery rule properties and change perhaps the community string which was invalid for this particular device. Now, discovery failures usually occur most commonly for a couple of reasons. One, the device itself is unreachable from a particular management server. 2, there's some type of firewall configuration that's preventing traffic between the network device and operations manager. Those are probably the 2 most common failures that we've seen. And we try to give you some information there in pending management to help you be able to diagnose that. So let's switch back to PowerPoint before we go a little deeper into the monitoring aspects. So let's talk about, we just showed you how discovery is configured and how you run it. Let's talk about also what we discover now. So as I mentioned in the onset, it's not just discovery of those devices that's interesting. It's discovery of those devices and how those devices are connected to one another and how their performance impacts the devices that they're connected to and the servers that are connected to those devices and the applications and services that are running on those servers. In addition to that, we have the ability to discover the VLANs that are existing on your network and also what endpoints are participating in a particular VLAN. And we're able to do a health model roll-up of that as well. For some of our Cisco customers, we support HSRP groups for high availability monitoring of those groups. We're also able to monitor key components of a device. So we're talking the individual ports and interfaces of a device, which we, from talking to customers, have realized that's really the bread and butter of what monitoring value they will get from this feature is the port and interface monitoring. And also some monitoring of some peripheral devices, components of devices in processor and memory for a subset of our devices that we support. So as I mentioned before, we had 2 discovery methods, and I kind of want to just highlight that explicit discovery is really our mainline scenario. 70 to 80% of the customers that we talk to here through our TAP would use explicit discovery to discover their network. While recursive discovery will provide you that initial flexibility to discover your network by giving you that network crawl capability. So let me talk a little bit more behind the scenes on what actually happens when we go and discover a device. So we break discovery into 3 distinct phases. And those phases are also visible to you in that status field you saw in the network device administration workspace. The first phase is the probing phase. So in this phase, we were going to attempt to communicate with the device via SNMP or ICMP based on what properties you gave us. Immediately, we'll know if the device was able to respond to that. If it does not respond to it, we drop the device to pending management and try to provide you a reason why we were unable to communicate with the device. If it is, we queue that device for further monitoring and interrogation. In the processing phase, we're able to now communicate with the device, and we know for a particular device, based on its object ID, we know what that device is in some cases, and in some cases we don't know what that device is. If we know what the device is, we have an internal mapping of a bunch of MIBs that that device will respond to, and will allow us to discover all of the components of the device, all of the ports, all of the interfaces, all the processors, the memory, in some cases even peripheral components like temperature sensors and voltage sensors and power supplies, etc. Once we do that, we kick the device over into our post-processing phase. In post-processing, now we start doing the next level of discovery, where we're actually discovering some of the top-level objects, like what VLANs is this particular device and its endpoints participating in? What devices is this connected to? And then we also do that key mapping. That is the mapping of those network adapters running on your servers and what ports they're connected to on those network devices, and stitching those relationships during the post-processing phase. Once we do that, we commit all of this data back into the Ops Manager database, and we kick off monitoring for our discovery. So I'll mention a couple caveats that I mentioned during the discovery demo, but I want to make them a little clearer to you and explain to you why we've set them up as such. So discovery, as I mentioned, only runs from a gateway or management server. We find that typically this is how customers wanted to configure their environments. So you could take any number of your management servers, assign a discovery rule to them, and discover your network. Or in the case of a gateway, if you have some devices that you want to use a gateway, you can use that as well. You have a single rule per device, but that rule can contain any number of devices that you want. So you don't have to have multiple rules across multiple management servers. You could have a single rule that you use for discovery, or you can split that up as you please. As I mentioned, our network discovery can run on a scheduled basis, so you can tell us exactly when to run it, or it can run on demand by you simply going to the administration workspace and clicking Run Discovery. Now, I will mention for some devices, we've actually enabled out of the box an automatic rediscovery based on device traps. So for example, some devices have a field-inserted FRU trap that they generate when a card is changed on a network device. So let's say one of your network personnel was doing some type of upgrade on a network device, replaced a card on the device. The device itself would generate a trap saying, hey, this happened. I had a significant configuration change. We're automatically listening for those traps. When we get that trap, we know, hey, there's been a change here. Let's go rediscover just that device. And we'll go and rediscover that device and discover whatever changes have happened to the device and make all those updates. And this happens all seamlessly for you. No additional configuration, no alerts need to be generated, no notifications sent out. This just happens and it just works out of the box. So let's talk about what's monitored now. So as I mentioned, the real bread and butter of the monitoring scenario here is being able to monitor your ports and interfaces. But not just monitoring whether the ports and interfaces are up or down. Even for up and down, it's not as easy as saying up or down. An individual port could be operationally up or down, or it could be administratively up or down. So some of the scenarios we've seen is, a network admin unknowingly may want to conserve resources on a particular network device. They may shut down a set of ports. Well, what if one of those ports was being used by one of your apps or services? Wouldn't it be nice to know that that port was administratively shut down so that you could have that conversation to say, hey, you know what, port 13 on this switch, I notice is administratively down. Can you turn that back on for me so that I can continue offering my services to our employees? You can also see the volumes of inbound and outbound traffic. You can view this in some of the performance views we built out, and you can also view this in a lot of the reports that we ship out of the box. You can see the % utilization of your ports and interfaces, and then you can also take a look at some of the low-level metrics such as the number of discards, the number of drop packets, the number of errors, et cetera. So you can really see when a port's misbehaving and it's impacting your services. And we've set smart default thresholds that when a percentage of your traffic is exceeding the threshold for any one of these things, we can automatically generate an alert for you and notify you that, hey, this port is potentially unhealthy and impacting your services. For some of our devices, we also provide discovery and monitoring of processors, so you can see when a device is overloaded due to processor utilization. And also we provide some memory monitoring. Across the board for the devices that we support memory monitoring for, we can give you the amount of free memory on the device. For some devices, particularly some Cisco devices, we can provide you some more in-depth memory counters, things such as buffer allocation failures or excessive memory fragmentation that exists on the network device as well. In addition to those peripherals, we monitor the connection health. So the connection health is really, in our model, an aggregate of the health of the two endpoints. So the health of the network adapter on the server itself and the health of the port or interface, and we can help you visualize what that health of that connection is through our Vicinity dashboard. In addition to discovering all of your VLANs, we can also show you the VLAN health as an aggregate of the roll-up of all the participating endpoints in that VLAN. So we'll know that a particular VLAN could potentially be unhealthy when any of its members are unhealthy. We can automatically show you that visibility to show you that a VLAN may be unhealthy. The same exact story can be said for HSRP groups as well. So in the onset we mentioned, and in the overview Joseph mentioned, the addition of resource pools to Operations Manager 2012. And resource pools and high availability is something that our customers have been begging us to add, and is something that we really need to add in our environments. In the former model, without resource pools, if one particular management server happened to go offline, you'd essentially have a blackout of monitoring of those particular network devices. We wanted to avoid this potential catastrophic scenario by supporting resource pools. So in the event that one management server happens to go down, he would automatically fail over his monitoring responsibilities to the other management servers in the pool so that they could continue monitoring those devices for you without any user intervention. Once that management server came back online, or if you brought up another brand new management server, we could automatically put back that monitoring workflow and redistribute that workload across the other management servers that are participating in that particular resource pool. So this is very powerful for us to be able to provide you high availability monitoring out of the box. One thing I'll mention is a lot of the work that I spent working with many of you in the TAP and many of our internal partners was being able to tune network monitoring to provide you the right amount of information. If any of you used our CTP1, for example, you would notice that out of the box, we would discover and monitor every single port on every single device that you have. What we realized was this is overload. This is not interesting, and we're giving you too much information, and too much information that's not actionable. So we thought, how can we be smarter about this? How can we tune this feature to be ready to be used out of the box without having you to go through and jump through hoops and turn off monitoring and turn on monitoring for this and that. And we wanted to be intelligent about what we did out of the box. So we decided the real ports and interfaces that matter are those ports and interfaces that make up connections between the network devices and those ports and interfaces that make up connections between your devices and the servers that you're monitoring. So by default, we only enable monitoring for those ports. Now, that doesn't mean you can't simply select an interface and click on a task to enable port monitoring. You certainly can. But we wanted to provide that out-of-the-box experience for you so that you would get the richest experience, the best scalability performance out of the box. I will show you when I jump over into the monitoring demo exactly how you can enable or disable monitoring for a particular port. We made that process much easier than it was in previous milestones as well. Last, so I've talked about all of this monitoring that we've provided out of the box. But how do we visualize all this data? How can we present this data in a meaningful way so that I'm not jumping through state views and performance views and checking counters and running Health Explorer and looking at all my monitors are running. How can I view this in a way that makes sense? So we built 4 dashboards, leveraging a lot of the investments we made in dashboarding for Operations Manager 2012 for network monitoring. The first dashboard is the network summary dashboard. So as Joseph mentioned in the overview, we have kind of an Operations Manager coffee break dashboard. This is our analogous experience for that. So it's sort of a top 10 list. So you can see across your entire network topology, what are my top 10 nodes with the slowest response time? What are my top 10 nodes with the most alerts generated? And from there, I can pivot into any of these other dashboards. So the network node dashboard lets me take any particular network device and drill down into that network device, and then show you things that are particular to that network device. Things like, what has its availability been like? What's its processor utilization been like over the last 24 hours? How responsive has it been? How many alerts has this device generated? What's the health of the interfaces that are on this device? And from there, we can drill down even more. We can take a particular port or interface on that node and drill into the interface dashboard. There, for a particular port, we can show you some of the bandwidth utilization, the amount of inbound and outbound traffic going in that port, the types of traffic and packets, whether unicast versus broadcast, inbound and outbound on that particular port. We can show you the numbers of errors, discards, drop packets as a percentage of the total volume, and that kind of information. Right in a nice, pretty dashboard that you can then view in the web console, on the Windows console, and also publish to SharePoint. Last, we shipped 5 reports out of the box. So a lot of the feedback we've gotten over the years was, we love Operations Manager's reporting capabilities, but we hate authoring reports. Can you please help us? So we wanted to ship to you 5 useful reports that you could leverage out of the box without having to do anything. So we built 2 resource utilization reports for memory and processor, and then we built 3 reports for your ports and interfaces. One based on traffic volume, one based on an error analysis of the types of traffic going in and out of a port, and the other one that will give you a breakdown of the types of packets and bandwidth being used by a particular report. So let me switch over to the demo and show you what that monitoring workspace looks like. So in the monitoring workspace, you'll notice we built out a network monitoring view. The network monitoring view will allow you to see all of the views that we've built out for this feature. So the first dashboard you're going to see here is the network summary dashboard. Now I will mention, this is an actual running lab. These are real devices. This is a real Operations Manager deployment monitoring real components. So bear with me in case, you never know what happens with the demo gods. But I want to mention to you, this is not a screenshot. This is not demoware. This is actual live running monitoring that's taking place here. So the network summary dashboard is a great first place for you to come and see how your network's behaving. As I mentioned, right on the get-go, you can kind of see what are my nodes with the slowest response time. That response time is determined by that responsiveness to that ICMP ping, and what's its average time been responsiveness in the last 24 hours. You can also see the nodes with the highest CPU utilization over the last 24 hours, the interfaces with the highest utilization, the interfaces with the most send errors, most receive errors, as well as the nodes with the most alerts and interfaces with the most alerts. Now, a lot of the categories that we came up with here, we found out by talking to you guys, our customers, and I want to thank you guys again for your feedback that you've submitted to really help us understand from you what are the real key areas that you care about in your network, and how can we help you visualize those components. So if I'm curious for a particular network device now, let's say I take this device I have, and I want to find out more information. You can see our navigation tree provides us a few options. So if I pop open Health Explorer, you can quickly see what monitoring we're actually doing at the node level. So let me zoom in a little bit here, make it a little easier for you to see. Let me expand it out. So availability and its health availability, which is its ICMP and SNMP responsiveness. You'll notice we've embedded very detailed knowledge within all of these monitors so that you can understand very quickly exactly how we're determining health of this entity. And just like everything with Operations Manager, you can easily override any of these from Health Explorer as well, or disable any of the monitoring as you see please. On the performance side, you'll notice I've got memory and processor monitoring. So you can see the various memory modules I was able to monitor. You can also see any of the processors I was able to discover as well on the network device, and then their associated health. One of the nice things we did for performance collection on processor and memory is we came to know that not all vendors present their performance data in the same way. For example, some vendors may show you percent memory free. Some may show you percent utilized. It's not useful to you to see those two counters side by side or for you to see those monitors side by side. So behind the scenes, we normalize all that data so that you can actually compare a device from vendor A and a device from vendor B and be able to get meaningful comparisons out of that. So let me jump into some of the other navigation views. So we have our traditional alert view, event view that's going to show you any of those types of things generated, as well as a performance view, which is going to show you all the performance counters being run for a particular device. But let me pivot into one of the other dashboards I mentioned, which is the network node dashboard. So the network node dashboard will give me a dashboard targeted at a particular network device and show me all the properties that I really care about it. So right quick in the upper left, you can see a vicinity view. That's going to show me what initial one-hop neighbors I have to that network device. It'll show me the connection of the health between those devices as well. I can tweak the number of hops here to show any more devices downstream. I can also check show computers, which will show me what Windows computers that I'm also monitoring that are connected to this device as well in this view. So you can kind of see that this network device is connected to these other Windows computers that I'm monitoring as well. Average availability kind of gives you kind of like some nice gauges over the last 24, 48 hours, also the last 7 and 30 days, so you can kind of gauge from that perspective what your uptime of that device has been over those time frames. You get the average responsiveness to ping over the last 24 hours, so you can look for any abnormalities that you see there. We provide you the min, max, and average values there. Processor utilization is also provided. And also these properties that we're able to read off the device itself in the instance details. So all of these device properties are actually read off the MIB tables of the device itself so that we can bring into you quickly a bunch of information about the device without having you to run your own SNMP gets or having to telnet into the device or having another third-party tool interrogate the device itself. So you can see that all very quickly. Next, you get the health interfaces of the health of all the interfaces running on the node. Now you'll notice in this list, there's a bunch of ports and interfaces that don't have that healthy or monitored check mark, but then there is a set of them that do. So this goes back to my point that I was mentioning. Out of the box, we want to enable the right level of monitoring. So in this case, we've got, it looks like 7 ports monitored, and those 7 ports are interesting because they made up connections between network devices, or they made up connections between this device and one of the other devices I'm monitoring. But if I want to enable monitoring for any other set of ports, I can simply select those and check one of our interface tasks to enable port monitoring. It's that simple to enable monitoring. We'll automatically turn on the appropriate monitoring workflows for that. Conversely, you can also disable monitoring in the same easy selection. In addition to that, if I select an individual port, I'll mention one last view, sorry. The active alerts would also populate in this view. Now, if I care about a particular interface, I can drill down even deeper. So I can now pivot to what we call the interface dashboard. Or I can also pivot directly into those 3 reports I mentioned to you that we have as well. So the interface error packet analysis, the traffic volume report, et cetera. But let me pivot into that interface dashboard and show you how we've been able to visualize some of that data. So you can see from here, I'm looking at kind of the bits sent and received over the last 24 hours, broken down by inbound and outbound, the types of outbound and inbound unicast packets that we've seen sent and received, any number of send or receive errors, any discards, both input and output, your network utilization, and again, any active alerts on this interface. The instance details will give you information like the maximum speed that the port interface is configured for, and will also give you the common name alias as well as any other properties that we're able to query on the particular interface. So let me switch back to our legacy view here and show you some of the other views we've built out. The network devices view will show you at a quick glance an enumeration of all those devices that we talked about. We'll get the name of the device, the physical location that the device is located in, if that's specified on the device itself, the make and model of the device, and also the IP address that we're able to communicate to the device via SNMP with. And then for any particular device, you also have the ability to do some node tasks. So while I mentioned that the majority of our functionality is to provide monitoring data, we'll provide you a quick way to launch a telnet session to the device if you have the appropriate credentials. We also have the way to do an SNMP walk of the device. For us, we added this capability as a nice troubleshooting step for us so that we can essentially simulate this device in our lab and be able to reproduce any issues that our customers were having. So we provided that functionality. We have the ability to do an SNMP get, which will let you specify any OID and probe the device for a particular value if you want to probe any of your individual devices via SNMP, and also provide you the ability to generate a ping on the fly. We've also built out some state views for things like VLANs. As I mentioned, you can very quickly see the health of any VLANs, as well as HSRP groups there. We have some performance views set up as well. If you want to look at device responsiveness and you want to compare multiple devices, you can do that in this view, as well as look at any of the processor or memory utilization that you have in your environment. Let me switch back and show you the vicinity dashboard now. So that vicinity dashboard was really that network topology view that allows you to visualize how your network is, your network's health and how your network's connected to each other. The one thing we wanted to do is we wanted to make it really easy to get to that view. So you'll notice you can get to that vicinity dashboard in a variety of ways. You can specify any node that you want and click the vicinity dashboard. You can select any interface from any of the views and get to the vicinity dashboard. But most interestingly, you could select any alert targeted at a computer, for example, or any Windows computer itself and pivot to that dashboard. And this is really useful. So if you know that there's something that's been going on that you want to see is impacting one of your computers, you could select a computer. In this case, I selected this OM Network 06 box, and I can click Network Vicinity Dashboard. So what this is going to do is show me exactly how this server is connected to my network and what the health of those connections are. So you can very quickly see the one-hop neighbors to that network device as well as the computer that I care about itself. As I mentioned before, I can blow this out even more by increasing the number of hops, and I can also enable show computers here. Now, I will give another public service announcement. If you've discovered hundreds or thousands of devices in your environment, if you increase the number of hops, this may return a very, very large network map. So you may want to use some caution when doing that, but you can kind of see what this looks like now. So very quickly, I can see exactly the servers that I'm monitoring, the health of those servers. I can see the network devices that I'm monitoring, and I can see how all of these devices are connected and relate to each other. I can even see that this connection is unhealthy, and I can pivot from this connection. I can see exactly what port on this device this is connected to. I can see the MAC address of the network adapter itself. I can pivot then to Health Explorer or any other alert views from that particular interface. I can also pivot to any of the reports themselves. But very quickly, I can visualize all of this information and all of this health information from one consolidated view. And as we mentioned, this view can then be exported to SharePoint, where you could publish this data so that people can see that, a visualization of the health of their environment. You can also use this in the web console and those other consoles as well. So let me switch over back to the summary dashboard, and I want to show you some of the other things we've done at the port and interface level as well. So for a particular interface, I want to kind of give you an idea of kind of the detailed port monitoring we're doing. And one of the easy ways I can do that is by popping open Health Explorer and showing you all of the metrics of things that we're collecting on a particular port. So as you can see here, we're not just monitoring that the port is up or down. We're giving you both administrative and operationally if the port is up or down. We're collecting performance information about things that you really care about that could really impact your services. if the number of collisions is high, if there's a high number of discarded packets, both input or both inbound or outbound, if there's a high number of error packets coming in and out, if the queue drop rate is high or low, and also if the utilization gets too high or low, you can kind of see exactly what's going on there. And again, by default, we've configured these monitors by looking at customer environments, talking with network engineers and understanding really what it means for one of these things to impact your services. And again, you have the ability to override or disable these as you please. You have that flexibility there. Last, I'll show you one of our how our reporting works. So let me click on, so I've got this port selected, and let's say I want to take a look at some of my interface traffic that's been going on for a particular port or interface. So by clicking that, it will automatically launch me into my report view. I can set up whatever the appropriate unit would be, whether it's bits per second, kilobits per second, depending on the type of connection, you can specify that. You can specify a time range that you care about. So let me look at, let's say I'll do over the last day or so, and I'll do hourly data aggregation. That should give me a nice report. You can also specify to run the report only using business hours, which is very useful. May not be that useful to see what's going on a particular port outside of business hours. So if I run that report, very quickly we'll be able to leverage SQL reporting to generate a report that can show me over the last 24 hours what my ports traffics look like as inbound and outbound. And then I can even drill down even more to that. So let's say I really care about this spike right here that I'm looking at. So if I click on inbound bits per second, this will actually show me all of the data collection that was performed on this. You can get some nice charting to show you kind of, look, there was a great standard deviation around 11 a.m. or 11 p.m. yesterday, and I can dig down deeper into why that may have impacted something. The detailed table will also let me see every single performance collection that took place on the device and what those values were. So very quickly, you can get access to all of the monitoring data that we had in a report that took, like you saw, under 10 or 15 seconds to run, and you didn't have to do anything to do it, and you get this nice report that you can share out with your stakeholders and your network team even in there. So let me switch back and wrap up, and then we can talk about some of the things that we did. So in addition to all of that monitoring that we provided out of the box, one of the main things we wanted to do was ensure we were delivering a platform for network monitoring for our customers and our partners to leverage and extend as well. So in addition to the monitoring that we provide, there is also the ability to author your own SNMP rules and leverage the SNMP module that we ship out of the box to do monitoring of essentially anything that responds to SNMP. This will allow you to author custom management packs against devices that we discovered and monitor things that we may not even be monitoring. One of the other big things I want to drive home is we wanted to provide a good experience for not only those network devices that we know about, but nearly generically across the board, we wanted to provide good network monitoring. So what we did was we followed a few industry standard MIBs, and we were able to provide port monitoring across nearly all network devices that respond to these two industry standard MIBs. And in our practice, we've seen that will allow us to get port monitoring almost up to 90 to 95% of all the devices that we've been able to throw this at on all of our customer environments. And that's very powerful, because that means that if a device comes out next month or in 2 months, or you have some device that you have that's not even known, there's a good chance that monitoring is going to work for that device without you having to do anything. As well as we want to build the ability for you to be able to add the right level of monitoring for your scenario. So the authoring experience that we've built in using the SNMP rules will allow you to do that. So just kind of recap, I hope you guys all saw today how Operations Manager will allow IT Ops to get that visibility into their network layer of services, and with that information, how they'll be able to communicate that to their network team or have the right amount of information to understand how your network devices impact your services and applications. I will be available for Q&A up here if any of you have any questions. I would ask if you complete the survey, we get to come here or not come here based on your feedback. So I would appreciate any feedback you have, and I'll be available to you guys. Thank you.